that this program, BME Idea Latin America, BME Idea Africa, BME Idea Asia Pacific, Europe, and US, these are so critical to us working together, sharing best practices, exchanging students, exchanging faculty, and really working, and even sponsors and things like that to really help this community growth. So thank you so much for that. I'll say a little bit about myself and get into the presentation. So I have a PhD. I started out electrical engineering. Actually, I started as a history major at Rice University in Houston, Texas. And my father came to visit and said, "What are you studying?" I said, "I'm studying history." He said, two pieces of advice. One, no one's going to marry you with a history degree. You don't support a family with a history degree. Second, he said, be an engineer, because engineers are a bridge between human knowledge and human need. That really appealed to me. So I became an electrical engineer. At that time, there was no biomedical engineering. And then I went I did an undergraduate degree there. I did a master's degree in acoustics. I have some patents in elastography and illustrographic imaging with ultrasound. And then I went to PhD in biophotonics at University of Texas at Austin. And then I went to work at Johnson & Johnson, advanced R&D, business development, and then corporate science and technology office. When I was there, I was on the board of this department, and they said they wanted to create a program like Stanford Biodesign, and they want to bring someone from industry with an industry perspective, because they know that academic researchers don't get it. So that's how I ended up at Hopkins. Along the way, I also got an MBA from Wharton in entrepreneurial management. I'm faculty in the School of Medicine with appointment in business, and I'm the leadership teams of our Center for Global Health. We have an Alliance for Healthier World, the mHealth Alliance, on the board of VentureWell, Rice 360, and several other steering committees. I was also had the great honor to be at the kickoff meeting for BME Idea Africa, BME Idea Europe at the BioInnovate place in Ireland. I don't think
I wasn't there.
You weren't there yet. Yes, 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 yes.
The next year.
And then I think we met at Whitaker.
Yeah.
Yes.
I think we met 10 years ago.
Yeah. Wonderful. So this is a picture of 4 of our graduate students at a clinic in Nepal, and this woman is a midwife there. And what I love about the photograph, it really conveys that idea that everything we do in biodesign and medical problem solving is about being a good listener. Starts with careful listening. So these are 4 students. I love the diversity of the class. We have someone from Taiwan, someone from China, someone from India, someone from the United States. And they're all listening very carefully, and they're in the place where the problem exists. And they're looking around. She's describing all the difficulties she has in managing her cases, but you can see like she has a way to manage it. It's not like people are waiting for you to show up and solve their problems. They already have solutions, and you have to put their solutions that they've already developed in your landscape when you're doing competitive analysis, and not just think about the stuff on the market that's making money. Because for every problem, there are very creative people who care more than you about the problem, who understand the problem better than you, who are trying to solve that problem already. And they often have excellent solutions. The mission of our center is really 2 pieces. Of course, education and development of the next generation of leaders in healthcare, but also the creation and early stage development of the solutions themselves. And the metric of success is the impact of our students and our ideas on healthcare in the world. Believe it or not, this was controversial, because people said you're an educational institution, you should only do this. And this is not something that should be part of your mission. But in fact, we believe that these 2 go together, because your students will be energized and excited if the project they're working on is something that's real, has a real chance for impact. If it's something that is just something you made up for an academic exercise, that doesn't make people stay overnight in your design studio working and thinking and discussing and going to the cafe and drinking a lot of coffee to solve a problem. They'll go to sleep once they know they have an A. But when they've seen the people suffering from the problem, when they feel like they can do something about it, then you don't have to even give them a grade or motivate them. They will run them. That's why these 2 are really important that they go together. And we've done projects in many different countries around the world, because really most of medtech is focused in the richer areas, but the double-digit growth, even from a company perspective, the growth in our industry that every corporation strives to look for is all in emerging markets. So that's why it's so critical if we're training a leader that they know how to innovate, not just for wealthy people, but also for emerging markets globally. And you know, there's a huge problem in our field. This is not just design is not just a problem in other fields, but in medicine, it's incredibly lacking. And there's a lot of room for your skills and your talents to really have an impact. Just even EpiPen, my daughter uses one of these. She's allergic to bee stings. You know, every year in America, 34,000 people stab themselves on the wrong side. They push the wrong side. They'll take this off and, you know, they're having a crisis emergency quickly. They'll grab it and do this. And then you say, well, they're idiots. Of course, that's going to happen. You know, that's their problem. But someone's having they're in shock from an allergic response. And you have designed something that gives them no hint as to what direction if they can't see straight. So I consider this to be a design failure, not a failure of the users. Now, to be successful, there's 100 things you have to think about. So how can you even do this? Because unless you have a startup and someone gives you $10 million and you hire a regulatory expert, you hire a reimbursement expert, you hire a manufacturing scale-up expert, you hire all these people, you can't do it, but you can. You can do it if you follow a very good process. And I feel like starting these companies in an academic environment is really powerful. And how can you do all of these? Well, the first step that we follow, this is a process that we've developed, and it's based on learnings from J&J, from Stanford Biodesign, and from the software industry, how software is developed. And the first thing we do, we simplify by putting all of these concepts into 4 buckets. Just examples, but all of the clinical and medical issues and tasks fall in one bucket. All of the commercial related issues and tasks fall in another bucket, including regulation, reimbursement, competitive landscape, intellectual property, etc. All the technical and design tasks you put in one bucket. You can divide it up any way you want, but this is just to simplify. And then but this 4th one is critical that people ignore: organizational strategic thinking. Do you have the right people? Do you have the right resources? Do you have alignment with your sponsors? Let's say Boston Scientific sponsors a project here. Are you making sure the project aligns well with their interests? So those are all critical things for the success of the project. The question is, how do you do all of that? Now, when I was a PhD student, we did laser optical spectroscopy. And are you related to Herb Bijou? Yes. Yes. Okay. Yeah. Yes. So my advisor said, Youseph, you can work on whatever the hell you want to work on, but it better end up using the laser as the solution. Because if it doesn't have a laser, what are you doing in my lab? And guess what? I was very interested in cancer diagnostics. So we developed an alternative to the pap smear. Pap smear has like 60–70% sensitivity and specificity. It's not very accurate, but because cervical cancer is slow-growing cancer, you repeat the test every year, it'll catch it. And that resulted in cervical cancer going from the #1 most deadly cancer for women in America down to like number 13. And we came up with something better with 95% sensitivity and specificity. But it required $100,000 UV laser, optical fibers, 3 technicians, cost maybe $1,000 per test. And guess what? I got a PhD. I got papers published. Not a single person has ever helped in any way with this technology. Now, while we were doing the work at MD Anderson Cancer Center in Houston, in the small corner of the lab was this device, very simple. It looked like a French press. All it did was take the cells from the sample from the patient and put it on a microscope slide so the pathologist can read it more easily. So the cells won't be on top of each other. That's called the thin prep. It sold for like $300 million, very successful, commercially. But now like 90% of the pap smears in America use a thin preparation technique because it integrates totally with the flow, the workflow of the pathologist, everything. It's very successful. Now we looked at it, we poo-pooed it, we said this is This doesn't have a laser. This is nothing. I mean, it's like that joke from Toy Story, you know, like Woody, you don't have a laser, doesn't even have a laser. But, you know, we thought it was nothing, but it was actually quite effective. And the problem in most academic work is that you neglect all of these until much later. And you just spend years and years on this. That approach fails. The better approach, like Stanford Biodesign, is to start with the clinical need. Develop a keen, deep understanding of the clinical need at this point. Now you solve that need. Now that you've understood the need. And now you've solved it, you develop a business story around how to commercialize it, put together a team and resources, and you're done. Very wonderful linear process, very effective, and that's how most industry does it. There is a problem here with this process. Can anyone suggest what could be a problem with this process? Yes.
There is no time.
Yes, where should the loop be? To the clinical. Yeah, there should be a loop here, right? Yeah. And then maybe even a loop here. And maybe even a loop here. And maybe even the loop from here to here. So it's all related, right? So it's kind of like a little bit of arrogance because you feel like I've totally understood the problem and now I'm going to solve the problem. And I can tell you from my experience at J&J, we would talk to big shot key opinion leaders at like Cleveland Clinic, and they would say, I need this. And I would come back 1 year later, $1 million later, and say, here, Dr. Big Shot, here's the thing you said, here's the prototype. And you say, you know, now that I look at it, I really didn't need that. I already have that. I need something that was a little bit, you know, this other feature. And my boss would slap me on the back of the head and say, you just wasted a lot of money, and realize that designing a solution, an effective solution, is like hiking in the mountains. You have to start hiking, but you can only really see the 10 steps ahead of you. Until you take those 10 steps, you can't see the next 10 steps. So you really have to start moving, but you have to understand that you are developing your understanding of the problem and the need at the same time that you're developing your solution in parallel. So you're absolutely right. You need some sort of iterative process. Come back again and again because you cannot rely on your initial understanding. So the approach we take is something a little bit more complicated like that. So you start with you think of the whole space like a space you have to fill out to be successful. So the center is $0 and time 0. And as you move out in each of these, all your clinical understanding, you build it up over time, your commercial understanding, your technical work, your organizational strategic development, you work it out over time. You follow a path like this. So you start some medical problem. A surgeon says, I really need a device to do X. I wish there has to be a better way to do X. You come to this point in the path. Now you have an understanding there might be something here worth doing. And then you do a little bit of work on all of these different business-related things. What's already trying to solve the problem? How much of a cost to the healthcare system is that problem causing? You don't have no idea how you're going to solve it, but you can assess how much are people willing to pay to solve that problem, etc. And then when you stop here, you have an understanding of the constraints imposed on cost, usability, etc. by the clinical and business perspective. And then you could do some preliminary work on the design, and then you put together your team and get some funding. And then you stop and you say, does this project make sense? From all 4 perspectives, not just from a technical perspective, like my PhD. I remember when I was being interviewed at J&J corporate, they said, one of your jobs is to go and look at companies and assess good science and good technology and innovation and bad technology and innovation. I said, I'm the man because I've done both of those, good ones and bad ones. So at this point, you stop honestly and say, does this make sense? Should you kill the project? Should you continue? Should you pivot to a different need or a different solution? And then if it makes sense, you continue and you expand your understanding in all of these directions. You continue down to here, and then you stop again. Does it still make sense? Then you continue again, etc. The purpose is to build a strong foundation all of these. So you can do a little bit of work, and then you stop, and then you go a little farther. And the key is to go back continuously and ask more questions. And show prototypes and get a lot of opinions on this, and then go to the next iteration. That's the gist of the thought process. And you do it as a team with students and clinicians and faculty guiding you as the core team. But there's a problem. The problem is, for this to work, you need a broad range of experts from the very early stage. You don't have the $10 million of a startup. You only have maybe $10,000. How do you do this project? You need a lot of expertise. So that's where the good programs like our program, Stanford By Design program, your program, can really help the students. And that is bringing in a lot of partners who can just give a little bit of advice. You don't need a full regulatory expert, but maybe a half-hour conversation. You don't need a full investor to come on board, but half-hour conversation with an investor saying, is that problem worth going after? What would be your perspective as an investor? So that's why these partnerships are so important. And Cassie asked me to talk about partnerships. So that's where I'm getting. Cool. Yeah. So we've, of course, within our institution, we have a lot of partnerships. Across the School of Medicine, the School of Engineering, we have an NGO that does a lot of work around the world, Children's Hospital, etc. So within your own institution, you need to develop partnerships. But also outside of the institution, we've had partnerships with these companies and different law firms and regulatory agencies, etc. So these partnerships are really critical to being successful. And then, of course, the most important element of these programs are the students themselves. The students bring creativity, they bring passion. And the question is, how do we build partnerships with all of these critical people? These are 5 I just put up here, but there are a few others as well. The key is, how do you build a partnership? Because you need great students because they bring creativity and hard work. You need doctors to bring clinical access, project ideas, time and mentorship. Even sometimes they have solutions, even they have previous IP. You need corporate partners to help you validate things. And they also bring IP and data and funding, of course, that's what we usually think about them, and guidance on the projects as well. And investors, advice and capital. The advice is really important in the beginning stages. What is the investor perspective on this? Would they ever invest in this? Even if you solve the problem, we've had projects where the need is very strong, but an investor comes in and makes a strong case where no one will ever touch this as an investor, etc. And then philanthropists. They're an important part of doing this because this is not a very profitable thing to do early stage medical device innovation. You need some charitable support. So the question is, why would any of these people work with us? They bring value, critical value to our projects, our program, but why would they even work with us? So what you have to do is articulate a strong value proposition to each one of these. Why would a donor donate to your center? Because you have to provide to them, they're looking for a strong vehicle for societal impact. They want to have an impact. Bill Gates said it was harder for me to spend billions of dollars than to make billions of dollars, because he's desperately looking for people like you all to come up with good ideas to spend his money. But you have to have a vehicle to have a real impact. What do we give to students to entice them to work with us? The chance to have an impact. Of course, training and a degree as well. This is the most important relationship. When I got to Hopkins, I was told the most difficult thing you're going to face is getting the doctors to even pay any attention to your students. I can say after 12 years, the doctors, the biggest complaint I have is, how come you didn't take my project? How come your students are not working with me? But when we started, that wasn't the case. So we had to think very hard about what is it that would convince a doctor who's very busy and has 100 other more important things to do than to talk to me or you, what would convince them to work with us? So we really articulate the value proposition around it. Why would an investor, a VC or somebody, come and work with our center? So we've talked about what would be important for them. Why would a company work with us? So we talked about that as well. And the key is to build, for any relationship, you have a strong, balanced value proposition for each of these. Every one of the partners you're building has to have a strong, has to really be eager to work with you because it's very difficult. So that's really the gist of what the topic I'm going to cover is all about building these, paying attention to who your important partners are and making sure there's a strong value proposition for each one of these partners. So that's really it. Here's my email address. Feel free to contact me. You know, I'm very eager. One of my goals, I forgot, David, when you mentioned, why am I here?
Yeah.
I would love to learn more about the programs that are happening here. I plan on learning a lot the next 2 days. And this is my first time ever in South America, south of Mexico. So I really am eager to learn a lot and to form partnerships and build partnerships. Also, if you're interested in doing a master's degree in biomedical engineering, in biodesign, think about it, you know, us as well. But we've had some amazing students, and I've been exposed to some amazing talent like Pierre here from Latin America, and we'd love to have more students. So thank you very much for that. So do we have time for questions?
We do.
Yes.
I have a question. You mentioned the relationship with the doctor, the medical doctor. How it's very difficult to make them interested in our projects, the person of our students, or giving those interviews to absorb some idea about the projects. What would you say that was critical for the relationship that you said you have at the beginning with the doctors and the relationship you said you have now with the doctors, that they are eager to participate? Like, what advice would you give us to bring more doctors into our project?
I would say the barrier that we faced was culture. One of the doctors we worked with, the head of the neurosurgery department, said to me, I'm amazed that the university is doing this, because he started a company. And he said, when I started my company decades ago, the president of the university came to my office and said, listen, you're either on this side of the street or you're on that side of the street. You cannot play in the middle of the street. You have to decide, are you an academic or are you a commercial person? That was the attitude. That was the culture. And if you have a very successful institution like Hopkins, been around for more than 100 years, they don't want to change. They don't want to change the culture. They think we're already number one. Why should we do anything different? And this guy shows up from industry and he's saying we have to do something a little bit differently. That was not part of the culture. So there was a lot of resistance, a lot of dismissal, etc. But the way to change culture is to give good examples. Exemplars, evangelists, something to show people an example of, this is what I mean. So slowly we found that in the distribution of the doctors, we found the ones at the 3 Sigma doctors who were very excited about innovation, helped them a lot. They became successful, but we got the word out, a lot of marketing into the other doctors, brand rounds in the hospital, having those doctors talk to their peers, said, yeah, this is really exciting. And they're all wondering, how did you do that? How did you start that company? We have like the head of our spine surgery here at Hopkins. He started 2 devices out of our center, 2 device companies, very successful financially as well. So the stories start to get out, people get excited about it. And then the clinicians, every doctor you talk to has 1,000 ideas about how to do things differently. In medical school, they're repressed. No medical student dares speak up and say, you know, there's got to be a better way to do this, professor. This does not make sense to me. They'll be kicked out of medical school. No one wants to question the big shot professor. But once they become practicing, they realize that the practice of medicine, the way it's practiced today across the world, is lacking and really demands new innovative thinking. And they have a lot of ideas. They have no idea what to do with those ideas. So there's a huge pent-up demand because of the old thinking and the old culture. So as soon as you bring some good examples, people start coming. And gradually, now we found that we are oversubscribed and the demand is much more than we can even have teams to work on. I think it's a slow process. It's like any cultural change.
I have 2 questions. The first one, the thing that you said that shocked me the most was the fact that you're competing against the 99% of the university that is trying to do things the same way. That's absolutely true. And for us, like in my entrepreneur role, that has been the biggest challenge of trying to convince the university. And how can you, I mean, you convince Hopkins, how can we convince Universidad de los Andes to try to make a bet on us on trying to continue with these projects, because that's actually a little bit linked to my second question. Because the students, we have them like in the School of Engineering, we have them for 1 semester in the course. So basically all they do is super fast. We try to, I try to push them into focusing on the need, identification, to try to go deep on that part, because I know that they won't get to the commercialization part. But if there was a chance that the university bet on these projects and we could continue them over more than 1 semester, maybe students would get a little bit farther. And it happens the same thing here. We have them here for a year, but still it's a very short time. And I mean, when you're talking about students, I assume that you're talking about graduated students that have more time to do it. But in the undergrad program, how can you get them like to keep on going on the same project? Your suggestion would be, okay, stick to a project and change the students, or try to focus on one part, because that's really kind of one of the things that we struggle a lot with, because projects die at some point.
I absolutely agree with you, and it hurts your relationship here.
Yeah.
If these faces keep changing. And the project, they get excited about it, they get all worked up, and then they have a great solution, then the end of the year happens, graduation, congratulations, here's your award, and they leave, and the doctor's saying, wait, what happened? I just spent hours and hours with your students and they disappear. So we thought a lot about this, and we had the same problem. So one of the responsibilities of our center when it was created is that it included the new master's program, but also the entire undergraduate design program in BME, because it was languishing. It was not very successful. So we were asked to help to redesign that and make it much more exciting. And now it is the most exciting thing students say, and we come to Hopkins to go to do that design team program. That's the most exciting thing they do in the entire 4 years. The students say, for 3 years, I was told, up until now, I took this course, I was told this is what engineers do. This is the first time I get a chance to actually do what engineers do. So, and now we have it for freshmen, juniors, sophomores, all 4 years they can be involved in some way. So to solve the problem you addressed, students can apply for a 2nd year continuation for design credit of their 1st year project. So that's one thing. Not all students will be accepted. They have to apply. They can continue. At the master's level, we're doing the same thing. We have a fellowship program. So out of the 4 or 5 projects every year, 1 of them or 2 of them maybe are really have come up with something that I would invest in, you would invest in. Mm-hmm. So we give them a fellowship opportunity to stay. They act as TAs, they mentor the new students, and they continue to work on the project for another 1, 2, sometimes 3 years. So you have to create an opportunity for the best projects, at least the best projects, to continue for a 2nd year, 3rd year. The second option, the second thing, so one is this continuing class where they can continue. The second thing is that the university has set up resources for student innovators. So across the campus, a few steps away from our building is a place called Fast Forward University. And it's a place where students can get space. Now they're no longer in the class, but they can have space, they can have a machine shop access, they can have a little bit of money to work on their projects after their 1st year. And the university is providing them a little bit of like a nest to grow these small new projects and help them get going. And small funds, $10,000, $5,000 for the team to work over the summer, $10,000 so they can work a little bit longer. Probably here it may even be that may go even farther, that amount of money, because 90% of the money goes to pay the student salaries. So you have to create some mechanism for the good projects to continue for longer periods of time. And then in some cases, the project continues and then a new group of students will take up the project. But there is some loss whenever you do that.
Sorry, in the way of teaching biodesign, would you say every student should have like a glimpse of all of that, or would you focus on I'm sorry, or you should like focus because you have a short amount of time to teach them something, which is the most critical aspect of, or where you should spend that year teaching, like in the first year?
Yeah, they need to understand all these issues. And it's not just for later. You need to know these issues here in order to design a good solution. when I was at J&J, we followed a very linear process in R&D. And I remember after working on a project for a couple of years, it was how to tell a doctor if they're doing, laparoscopic gallbladder removal. They go into a small hole and take out gall. And sometimes the doctor cuts the bile duct and there's bile spilling inside the stomach of the patient. They don't know until the middle of the night, the patient's in pain. So if there was a way for the doctor to know that the bile duct is leaking before he closes the patient, ends the case, that would be fantastic. So we invented a way to do that. Worked on it for a couple of years, did pig studies, all sorts of things. It's a lot of time on the technical side. And then my boss says, okay, you're ready. Now let's go talk to marketing. Go talk to marketing and find out there's some serious problems with our design from a marketing perspective. We talked to the regulatory people in the company. There's some serious problems. If I would have talked to those people, even had lunch for half an hour with those people a year earlier, I would have saved myself a lot of headache. I would have designed the solution in different ways to make it less of a regulatory risk and more easily to align with the interest of the customer. I would have made the cost of the product to be better aligned with what people would pay. I would have integrated it better into the existing workflow. And those are things I didn't pay attention to because I neglected them. So I would say students have to have a little bit of understanding of all of these issues. And teamwork is so important. We're all nerdy, introverted engineers, and we don't really like to work with other people or talk to other people or look them in the eye. So we need to learn how to work with other people on teams. And diverse teams with an engineer and a doctor with a big ego who's trying to push people around and a business person who thinks he knows everything, get them all to work kind of together. And that's an important skill. So I would say if your design team program explicitly, conscientiously, mindfully forces students to develop and to think about all these issues, you'll be much more successful. When we joined 12 years ago, when we started the program, this is all they did. Every presentation of the students was building a prototype, even if it was a meaningless prototype. It was building things that had no meaning and no use and conveyed no value other than to show that they know how to use a soldering iron and make something. So that's I think the critical part.
My question is more related to the other side because we're here gathered because we are passionate about like design and how to impact. But we most be aware that some students just don't care. For example, some students may be totally okay with getting a job at the office where they are just going to, review some data of a clinical study, and he will feel like he's succeeding in life by doing that. However, since we have this capstone design project, he's obligated to fulfill that duty. So how do the most difficult thing that I have faced when teaching is how do I get these students that are just taking another course to graduate to engage with actually the process, because they may just don't care about solving real life problems or having some approach to do things differently. So I don't know if you have faced that, or how do you deal to make students that are not that passionate about the innovation, design, or culture to actually commit to their projects?
Great question. I think the solution is to, first of all, let's start with basic human nature. Yes, people have that tendency, but people are complex. They have a tendency to want to do the easy way and get a job. But every human being aspires to do something meaningful with their life. This is one of our highest drives and needs in life. Every human being has that. Every student wants that. You just have to open their eyes and say, this course, this one-year course that you're signing up for is an opportunity at least to get a flavor of that, to get an opportunity to work on something meaningful. That's why the choice of the projects that you present to your students has to be, it's so important. Polyak likes to say the unsung hero of innovation is choosing the right project to work on, the right problem to work on. Why is it the hero of innovation? Because if it's not a meaningful project, then no one is motivated to work on it. You cannot motivate people with money. At least not your generation. I don't know what's going on with your generation. But yeah, my generation is very much motivated with money. That's why I became an engineer. But your generation, I don't know. I told the same thing to my son, and he became a history major. He said, Dad, I don't like money. I just want to be a history major. So that's fine. But you have to motivate them That's part of your job as a cheerleader, a motivator, as a coach. Not just to teach them how to solder and make things, but to motivate them. And the way to motivate people is to show them the problem. Let them feel and sense. It's the sense of empathy. That's the number one thing, is you have to go and see the problem. Have this person who is not interested in the project go and see people who are suffering from that problem. Maybe they're building a device to help somebody who's handicapped to walk. Force them, say, okay, in order to get a grade, you have to spend one day with this patient, let them see what their life is like. And they'll say, you know, I wish I could do something. I'm an engineer. I want to do something. I have the tools and the skills and the brain to do something. I want to help this kid. And that motivates them. So I would say, don't make any assumptions about people that they don't have the motivation. I would say you have not woken up their motivation.
It's more related to the health industry, your perspective. I would say, what do you think are the main motivations for this kind of project that are related by design to enter the health industry? Because in Latin America, all of that system is very high. In Peru, there is no digital health record in the majority of the hospitals. And it's a regulatory part, and also the doctors that are present. So, what do you think the main limitations are in this industry?
It's hard to say in general, because every project you're working on, you have to give some serious thought to this part of the story. Your team has to think about, okay, we're not going to be around long enough to take this all the way. If it's an IT solution, yes, you can actually build it. But most medical devices have to go through a company like Boston Scientific, et cetera, to become a real product, because they have the capital to make a manufacturing facility, et cetera. So you have to think about that exit, let's say call it the exit of the project, meaning you're handing the project over, you've got to a certain place, you hand it to a team that can professionally develop it and market it and distribute it, et cetera. It depends on each project, but all I can say is this. I don't have an answer to your question. All I have is a method, and that is you start thinking about that early on and say, who would be the partner that would take this forward? So one of the reasons we work with companies is not to give us money. We say, if you want to work with us, thank you very much for your money. We need the money, thank you. But we also want you to mentor the team and say, you know, what would it take for J&J or Medtronic to license this and take it into the company? Where does it have to be? What sort of evidence will it need? How much of an impact does it have to have? And even in the choice of the project, it has to be something aligned with the interest of a company or somebody who's going to develop it further, or the interest of an investor. So I think even it starts thinking about this answer to your question has to start from the very beginning of the process. You have to think about the strategic alignment with some potential sponsor, the exit strategy. What is the landscape of, like when you're working orthopedics, for example, you have to look at an orthopedic companies and say, you know, where are the gaps where there's no good products? I guarantee you, if you're looking at orthopedic products, you know, a company, and there's a gap where there's no good products, they're going to be looking for something to license that to develop. And if you provide that to them, that's alignment. That's how you do that alignment. Yes.
What was the whole biodesign process of the program itself? Because, well, how do you address where there is no medical technology either, where there is no investment landscape, or where is no philanthropic entities in order to provide money? Because you, as you said, you did some projects in countries like probably Nepal, in Asia, where there is no this landscape of resources. How do you address that? And how the biodesign program works?
That's an excellent question, and I'm here to learn, because it's easy. I make it sound like it's all easy. Like, for example, the question about the clinical, getting people in the clinic to get engaged. So I left out one important part of my answer, money. So I had to go and pay one day of the week of a interventional radiologist. It's not cheap. To spend time talking to all of his colleagues to get them excited about the project. So money played a role in opening doors and getting people excited. Mm-hmm. So I would say you have to, it's a big challenge but it's not insurmountable. You have to grow where you're planted. Within Peru, for example, you have to figure out what is the landscape. You're working on something that doesn't require mass, big manufacturing facilities, $100 million manufacturing facility or production lines. We do a lot of it in-house. So, and I've seen innovation like that. We've done projects in India where the teams there are doing phenomenal work with the resources they have. Plus, wealthier countries like the US and EU have a lot of grants. And there's a wonderful trend going on in USAID and Grant Challenges Canada and UK and others, where they're insisting on projects. It's a pain in the neck for people like me, but they're insisting the project has to have a local partner, not just in name, but a local partner in a leadership role in the project. So this is something you could use because USAID and other big pocketed donors, they have this drive to engage you living in Peru on your project for innovation. So they're pushing the people who usually get the money, grant writers in the US, to engage people in a real meaningful way. Like we work with Makerere University in Uganda. I'm going there in a couple of weeks with my teams to work on projects. And that university is doing a really good job of getting money from Johns Hopkins faculty, because every grant they'll say, okay, well, put us in the grant in the budget. So a considerable amount of money will be coming to their university and hosting the students, advising the students, mentoring the students, taking them out to different places. That's how they're making it work.
And we will have a session later on in the afternoon where we are going to talk about some of these things in smaller groups. So,
were there questions on the chat?
No.
Yeah.
Question, more regarding like to the clinical side, because I'm a medical student. Do you have like specific examples of projects that you showed were like cost effective or actually meaningful for the patients, and that you like could have like eventually develop with a clinical or with a hospital?
Yes. So Cassie, you told me not to show the example. You leave something out.
So,
I'll tell you why. We should save this for a little later. Also because we have the 3 people at Stanford waiting for us. Hopefully they are waiting.
yeah.
All right.
And then we let them say what they have to